Grateful for you all coming. I'm Ari Hershowitz, and I'm the CEO and founder of Govable. I do consulting with government, primarily the federal government. And I've been doing this for more than 10 years. My background's a little mixed. I'm a lawyer who got into technology to try and fix a lot of the inefficiencies of law. And when you work with government, you find a lot of corners of inefficiency. And my main goal today is to interest you in bringing technology to different government applications. Let's see. Okay. What I have done as a sort of lawyer technologist is to identify the problems that you see in different areas. I primarily work with the House of Representatives, the Library of Congress, the Government Publishing Office, which used to be the Government Print Office, and see how they're doing things now. Often it's either a paper-based process or a process that has been moved from paper but still looks a lot like the old paper-based process, and understand how that can be modernized. And a lot of the work that I do is working with documents. And the reason is that the government runs on text. It runs on different documents. And if you think about it, as a lawyer, you start with legislation, you've got regulations, you've got guidance. So all of the legal background is document-based. Then your interaction with the government in one form or another is some kind of document. And it started with a form that you filled out, and now some of those forms have moved online, but it's still text that you're sharing with the government. The government is sharing back its answers to you. So, the work that I've done in a lot of cases is not so technically challenging or difficult. The hardest part is to move the work processes and manage the change in government to move to new technologies. So one of the examples of where we put in Elasticsearch, and this is where, I encourage you all to think about different places when you're interacting with government websites, that basic search. We're not talking about artificial intelligence yet. We're not talking about LLMs or AGI. We're talking about basic search, where basic search can really get you a lot of what you want out of the interaction. The House Parliamentarian, interesting corner of Congress, collects precedents. And what's a precedent? A precedent is something happened in Congress. Often one congressperson called another congressperson a bad name. And they write down that this person called them a bad name, and it's either allowed or it's not allowed. So is jerk something that you can call another congressman? Well, in order to figure that out, you have to go to the precedents and see, has the parliamentarian ruled on this before? If in 1953, a congressperson called another congressperson a jerk and they allowed it, well, there's more room for allowing it today. And if they don't allow it today, you make a new precedent. You say, overruling the precedent from 1950. And they collected these from, the 1700s on cards, index cards, write a new precedent. You collect the speeches in the House that led to that precedent. And now you have a card index that you can look up. And the people in the office of the parliamentarian are real experts at this. Let's say there are 20,000 cards. You have the right person in the office, something happens on the floor, and they remember, oh, I think that was the card that's in the middle of the stack, right? So that's the way it ran until about the 1990s. They put in a SQL database at that point with SQL Search. And basically from the 1990s until I was contacted in 2019, that's the way it was working. And they were thrilled. And they would do their search, basically a SQL query for the words. So you had to have the words in the exact right order or you wouldn't get back a result. They'd wait their 3 seconds and that was good enough for them. And that's where we introduced basic Elasticsearch. We needed to transfer the SQL data into Elasticsearch. We needed to keep both current because they were storing their information in SQL, and that was pretty much the most difficult technical part. And then, and this is the part I would also encourage you to think about, we had to build a custom user interface. And let me just see where I can show that. The reason we built a custom interface is that lawyers in particular, but generally people in government, like their advanced search. So they like not only bringing in the search, but then doing a whole bunch of specific filters on different metadata fields. And I wished then, and I still wish now, that there was a really nice basic user interface search that we could add custom filter fields to that would make the customer happy. And this kind of application could work throughout the federal government and probably in the states and cities, because they have the same. If you look at these websites, I encourage you to go on to government websites. Every single government website has built its own custom advanced search with its own fields and has its own, and different ones of them use different backends, but it's the same concept repeated. And that's basically, so that was the work that we did for the Parliamentarian. We learned from that we could replicate this work in pretty much any office that uses text data and hasn't already done this themselves. And then we got contacted by the Library of Congress, and this is going to lead in, I think, to the next presentation in some ways. And their challenge was similar. They wanted to do search, but they wanted a particular kind of search. There are 20,000 bills introduced each year in Congress. One of the jobs of the Congressional Research Service is to summarize each bill. And in their summary, they do an analysis of the bill. So it's not, there are a number of people who have tried to run AI summarization, and it's not quite right because it needs to analyze the context of the bill, whether this bill is really repeating something that already exists in law. But that there are only 10 people in the office to summarize all 20,000 bills in the year. So it's a huge job. And what they want to do is they want to cheat. They want to cheat and get previous bills that they've already summarized that are pretty close, 80% or more close to bills that they've summarized before, take that as a basis and build on it. So we needed to build a similarity engine. And my first approach was to build it in Elasticsearch, and we showed them the results, and it was close. They got a relevance measure. They got the similar bills, but a couple of things were missing. One is that we needed to be able to focus on certain parts of the bill and ignore other parts of the bill. And then one of the things that they most wanted is to be able to find bills that were included in other bills. And sometimes that information gets lost with a strict search because you've got a teeny tiny bill and it's included in a 1,000-page bill, and they want that to be 100% similar. And then you want to go the opposite way, the 1,000-page bill matched that teeny tiny bill, and you want that to be a much smaller similarity. Right? And so that asymmetric similarity needed to be built in. So our first approach was to use Elasticsearch as a first pass to get all the bills that might be similar, and then do a normalized, quantified measure of the similarity of the bills. That was taking us too long because we had to go through all of the bills and run that quantitative measure. So we later went on to do a vector search and create an asymmetric calculation for the similarity of the vector search. So cosine similarity wasn't going to work because that's the same both ways. We needed to have a differentiable measure, and my colleague Selah Mador Chaim built this sort of search where the small bill going into the big bill would give you 100%, and the other way around would give you a smaller percentage, and it didn't sort of wash out into the average. And sort of, I would leave you on this note, which I guess I've emphasized before, which is that there are a bunch of applications throughout government that can use this very basic kind of search similarity. A lot of the tools that are already in Elasticsearch. I don't mind hugely because it gives me a lot of consulting opportunity to build on top of Elasticsearch to build these out. But I think there are opportunities for having a customizable UI that could be reused with Elasticsearch, and then also a more tailored approach to have tools that allow you to put in the full database of, say, the FAA or the FCC or the EPA, and do search on that, and then ask questions where you really could build some of these LLM-based queries on top of search. That's the big picture. I wanted to bring that to you, and very open to questions.
What's a RAG tool?
It's retrieval augmented generation. So you know the LLMs, okay. So it's the idea of bringing, having a tool in front of the LLM that does a search, picks out a chunk of text that's relevant to you, and then feeds that with your question to the LLM, so that your question is augmented, it's added to with some intelligence from your data set. It's often used like as a lawyer. Lawyers will have their document set. You know, I've worked on 20 cases, and I only want to search stuff dealing with my cases. So first, my tool is going to search my cases and get the most relevant chunk from, you know, my case 2 years ago. Then ask the question, and the two of them are going to go into, those two pieces are going to go into the LLM. Yeah.
So what are some concerns that you have as a consultant, or what are some concerns around, I guess, working with the government and, you know, with this type of search capabilities? Like, are there any caveats or anything that's unique to government side that we wouldn't normally see?
Well, so in the applications I've been working with, yeah, it's a great question. One of the criteria is the need for accuracy and correctness. You know, you're publishing this on behalf of the government. So some of what is allowed in general search, you know, if you go onto Google and Google something, you don't expect the answer. You expect a bunch of answers, and maybe I'll pick one, right? And so a lot of the tools that we're building for government are geared much more towards getting the correct set of data. And that goes back to the similarity criteria that we were using. The library wanted to know, is this document 80% text similar to that other document? Because if it's 78%, we're not going to include it in our list of related documents, you know? And so there's some level of quantification that you can't get away with.
And that's that was leading to the next question, was about that asymmetry within the vector search. Because if you're, what you were saying, like, if you have a criterion like that must be really difficult to be able to calculate. Like, okay, well, it might be 78% relevant, but it's out of a 1,000-page bill, and it was the subsections, right?
And that's why relevance metrics weren't going to work for this case. And one of the use cases for that is actually that there are a congressperson proposed a bill, but since Congress is so dysfunctional nowadays, it doesn't pass very many bills. It passes 30 or 40 bills. So the Congress people who want credit for their bill passing, their bill usually doesn't get passed by itself. It gets passed as part of a much larger bill. So they want to be able to claim with some credibility, my bill was in that bigger bill. And if their bill got torn apart and only a few words are in it, they can't claim that. If they got a whole chunk in there, they want to be able to say that.
And this is why it seems to me that vectoring and using, you know, this type of technology makes it much more efficient than using a traditional SQL database. Yes. Or something that's a relational database, I should say.
Yeah, I mean, it wouldn't be possible to get the quantification that we needed.
Amazing, thank you.
Yeah.
Did your system also calculate things like edit distance, like synonyms, was doing the vector searches?
We tried a whole bunch of different similarity metrics. Edit distance would be but very, 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 very difficult because you're dealing with large documents. And so the algorithm to calculate an edit distance for that would be really hard. We tried it at different chunk levels. So we take small chunks, match them up, see how similar those chunks are, and then have some algorithm to calculate overall how similar it is. And what we ended up doing, and I had hidden this a little bit, we vectorized using n-grams. So,
What did you use?
n-grams, so 3 or 4 words in a row. This is also probably not so technically correct, but it's lawyerly correct because if a phrase of 3 or 4 words is the same in one place and then or another, is the same in 2 bills, it's more likely that they're dealing with the same concept. If you only look at single words, if you're doing vectorization at the single word level, you got a word salad and the text could have moved those words around and no longer has the same meaning. So that's as close as we got. There's still a lot more work that could be done to be precise, but we took section level chunks. We got the 3 grams or 4 grams, quantified them, and then said how many 4 grams of this group is in this other group, and then did the opposite and said, and over since this chunk is bigger than this chunk, we normalized that way. So the larger chunk got penalized for being big. And that's how I'm hand waving, but that's essentially, thanks. Yeah.
Yeah, I kind of have a 2-part question. So the first one is kind of curious how the evolution from like SQL into Elasticsearch, like were you already familiar with like Library of Congress? Were you already familiar with Elasticsearch and you bid the contract, or like were there other technologies you considered? So that's one. The second one is more technical. It's like, how do you really evaluate like the accuracy of your product? Like it's not I would imagine it's not like it's not getting a lot of traffic where you just have like free testers that can report, right? Or so maybe.
This is a really specialized area, right? So both of those are good questions. I'll take the second one first. Okay. Our clients at the Library of Congress wanted 80% to be the cutoff between a good bill or a good match and a not good match. And there are many different ways you could calculate whether this is 80% similar to that other bill, right? What we did was we tried a couple of things. We gave them a list of what we found at 80% and let them tell us, oh, you're missing one. Well, if we're missing one, then our criteria were too strict. And we had to go back in and adjust. Does that make sense? So it's quantitative, but it was adjusted by the user interaction with it, because what we were ultimately after was not just saying this bill is 80% similar to this other bill. It's that this bill is similar in a way that matches the expertise of these lawyers who've been looking at bills for 10 years. Okay. Does that make sense?
These cases, like they can pull from previous bills and look at them really like just.
Yeah.
Okay.
So the use case is they've got 10 years worth of history of bills and a new bill comes out today. They know all those bills because they read them before. They have an intuition of which bills, but it's a huge amount. So then they do a search on the new bill. And if one of their old friends that they know should be in that group doesn't come up, we've missed something. Right?
Okay.
So, and we can justify the quantification by showing you, yes, if we chop off this part of the bill and that part of the bill, we do the n-gram vectorization, we do the matrix multiplication, it comes out with 83% for these 2 bills, right? But the way we got there was through iterative development. And that's why if that hadn't worked, we would have worked on it. We would have come up with a different algorithm. Does that make sense?
Yeah.
And that also goes to how we decided to use Elasticsearch. I love Elasticsearch. It's easy to implement. And that's also really critical for these applications. We needed to be able to put in a technology that that my clients could work with after I leave without any problems. And basically, we put it in 2019. We updated to Elasticsearch, I think 7. And then we've left it since, and I haven't had to touch it, and the system just runs. Does that make sense? Which also, that's an issue because upgrading to the next Elasticsearch will be will be a struggle for whoever decides to do that. But that's government applications. Sorry, yeah.
So I guess what are your metrics of success? How did you improve the overall system there? Like, what were the big wins?
Well, it was just we met with our clients once we had an MVP, we met with our clients every week, showed them what results we had gotten, and let them give us feedback or pushed them to give us feedback. And we just kept doing that until they were getting consistent enough results.
No, I didn't mean that. I meant like, so they were doing this, with flip cards, right? And so you guys came in, you guys used, the search, I'm sure it's changed the way that they're doing stuff in Congress, right? So like, what are those types of what's next for them, I guess, is what I'm
Well, that
asking.
gets to your question, and this is, it's a bit of quantum development because a lot of the people we're working with don't know it's technically possible. You have to suggest it to them. Then you have to convince them that the effort to do this next thing is worth it because a lot of them have patience. They were not bothered by waiting 2 or 3 seconds for the SQL search, but they're thrilled now that they don't have to wait, right? So getting them to the point where you say, this is not so hard. We can do this in a couple of months and you'll have a much better search. That's part of the sales process or discussion with them.
Well, I guess what I'm wondering is is your vision or the vision here complete? Or is there, what is can you share with us, what's the art of the possible?
Yeah, I mean, bringing it to this group is hopefully getting folks in Elasticsearch or other to think about government documents as a space. I know as a space of huge possibility. There are a few things that I think they'll need. The user interface is one of them, and then being able to take their set of documents, put them in, and get a non-hallucinated search result would be huge. And if anyone wants to talk to me about places to do this, so the IRS, the FCC, there are so many places that have this both for their internal work and also their external facing sites. Go to any of their sites, and if you're satisfied with their search, then I'm wrong. And typically that hasn't been the focus of most search companies, right? So that's part of why I'm bringing it here. I found in Elasticsearch really, really good search because it's trying to satisfy the technical audience. Do you know what I mean? And I would like to bring that to the non-technical audience that doesn't really know the possibility. Thank you, guys.
Hi, this is Yulia from the Amsterdam Elastic community. Hope you enjoy this meetup recording. You can join the local meetup group to go to in-person events in your area in the description link below, and hope to see you at our office soon.